Okay, so we're going to start chapter 3, section 4, last section of this chapter. And the title is Elements and Compounds. So again, we need to be on page 84 in our textbook. Make sure you've got a calculator available and your periodic table is somewhere at hand. It is that green sheet I gave you the first time I saw you. Everyone good? Okay. So the main idea of this section, a compound is a combination of two or more elements. Now you already know what holds together the atoms in a compound. What holds together the atoms in a compound? Anybody remember? Claire? Ooh, that's a good one. Anybody else? Gravitational pull. What else could it be? What's connecting those things? Claire? A chemical bond. Good. Now, gravity is what gets them close enough for that bond to take hold. Good. No. Gravity does affect everything, especially on that tiny little scale. So very good. Okay. So we are going to quickly get through this section. We got to talk a little bit about proportions. So let's go ahead and get into that. First question I'm going to ask you today, what distinguishes elements from compounds? How is your periodic table organized? And what are the laws of definite and multiple proportions, and why are they important? So notice that last question is two parts. What are the laws, and why are they important, okay? So when I ask you about that and you only answer part of it, you're not going to get all the points. You with me? Okay, so let's keep moving forward. Oh, went too far. Okay, our review vocabulary for this section is proportion. That's on page 84 for you. I'm sorry? Oh, proportion. The relation of one part to another or to the whole with respect to quantity. So we have a whole lot of new vocab this time, so it may take you a few seconds to get that written down. Just raise your hand if I start moving too fast. You with me? Okay. All right, an element. An element is a pure substance that cannot be separated into simpler substances by physical or chemical means. There are 92 elements that occur naturally on Earth, and each element has a unique name and a 1, 2, or 3-letter symbol. Now, this textbook was written before we got the names for the last few elements on the periodic table. So that last little bit's not true anymore. If you guys look at my periodic table on the wall over here on the right, numbers 115, 113, and 115 through 118, they all say UU something. Those were before they were named, and it was like whatever 100 is in some other language. And we didn't have the numbers there for, or the actual names for those yet, because we hadn't had enough of a sample to study. At this point in time, all 118 have a name. And if you look at the periodic table over there on the left of the room with the colors, you'll see the symbols for all of those. Tennessine or Tennessine, I don't really know which pronunciation is correct, was 117. So we're forever on the periodic table, which is kind of nice. So keep in mind, everything now has a 2-letter symbol, so don't just skip writing down 3-letter on there. Okay, questions? Okay. All right. What is the periodic table? It organizes our elements into a grid of horizontal rows that we call periods and vertical columns that we call groups. Horizontal rows called periods and columns that we call groups. missed it. If elements are in the same group, they have similar chemical and physical properties. The reason we call this the periodic table is because as you hit a certain number of elements, you start repeating. So we've lined it up to where those are all in the same group. Groups go up, and a period's at the end of the sentence, and we write our sentences left to right. A compound is made up of two or more elements combined chemically. A compound is made up of two or more elements combined chemically. Most of the matter in the universe is in the form of compounds, or it's a mixture made of compounds. Table salt, which is NaCl, we've talked about that. Water, H2O, are compounds. The big difference though, I can break those apart. I can break sodium chloride into sodium and chlorine. I can break water into hydrogen and, come on, what's the O stand for? There you go, oxygen. Good. Now, what kind of change must I do to get sodium from chlorine? Whoa, look at that. Yeah, good enough. Just a bit of a delay. Woo! That one went down. What kind of things must I do to separate them? Chemical changes. Good. Okay, so remember, for us to do, to separate compounds, we have to do the chemical changes. One is what you see in front of you. This is the electrolysis of water. This picture is at the top of page 88. So if you can't see it well on my screen, go to page 88 and talk to me. What are we doing here? Okay. Heating up the two poles. What else might I be doing here? Oh, good. We're making vapor. What's that thing at the very bottom? That's a battery. So I'm running a charge through water. And depending on which one is attached where, so if you guys will look closely, over here on the left, it's called the anode, which is a negative charge. And a cathode is on the right, which is positive charge. What do I get from the one on the right? What? Good, I get hydrogen. From the one on the left? Oxygen. Ooh, which one seems to be taking up more space? Hang on. Look at the gases right here and right here. The hydrogen's taking up more space. We'll go over why in just a little bit, okay? So if you notice, as the oxygen's bubbling out and the hydrogen's bubbling out. Oh, I know why. Why do you think? Because there's more gas. More gas than liquid, okay. Think about what's the formula for water? H2O. Is this roughly twice as much gas as there is here? Oh, it has to do with that ratio, huh? Okay. So that's one way to separate a chemical compound. Take a look. Didn't we talk about this flow chart before? Yes. Matter is broken down into mixtures and pure substances. On the pure substance side, we talked about elements and we talked about compounds. On the mixture side, what are the two types of mixtures? Heterogeneous and homogeneous. Now you see some examples down there at the bottom. I really can't get this thing to pull it down any further. Maybe I can. look at me. I'm talented. Okay. Now, if you notice, this will describe any type of matter in our known universe. You with me? Any type of matter. This is at the top of page 87 if you can't read it, because I am about to switch the page. But don't forget, everything falls into one of those. All right, here are the new ones. So this is going to take us a minute, okay? You need the definition for the law of definite proportions, and you're going to need this percent by mass formula at the bottom, okay? Okay, can we see it all? Get the definition for the law of definite proportion, and then make sure that you write down this equation down here at the bottom. Oh, I'm gonna mess this up. So let's chat. Law of definite proportions says that a compound is always composed of the same elements in the same proportion by mass, no matter how large the sample. How large or small the sample. There we go, got it. Now, when we're talking about percent by mass, this is constant, okay? This is how I determine if two different compounds have the same elements or not. So, when I show you how to do this, I'm going to show you first with data given to you, and then as we go through the year, I'm just going to tell you what the compound is, and you'll give me its percent by mass, okay? Are you ready? Mm-hmm. Do you have a calculator? Mm-hmm. Here we go. Like we said before, water is composed of how many hydrogen to oxygen? What's the formula? H2O. So there's twice as much hydrogen as there is oxygen. Okay, hang on. I'm having a computer issue. Shocker. This table that's at the top of 88 demonstrates that the percentage of elements in sucrose remain the same despite differences in the sample amount. So, if you look at sucrose, what elements is it made of? What's it say? What elements are in the sucrose analysis? Carbon, hydrogen, oxygen. Good. So when we're talking about it, take a minute and look. It tells us that our first sample, which is 20 grams total, has 8.44 grams of carbon. You with me? If it's a 20-gram sample, 8.44 grams of that are carbon. Now take a look. They put the mass of the element over the mass of the compound times 100. So we're going to practice that. Type in 8.44 divided by 20 times 100. Let's see what we get. Okay, so we got 42.2. Now look over at the second column there. If I had 500 grams of sugar cane, which is the same thing, 500 grams of sugar cane versus granulated sugar, and 211 of it were carbon. Divide those two. 211 divided by 500 gives me what? We're just checking this first row here. 42.2, good, and I just wrote all over my paper. 211.0. 211 divided by 500. Times 100. Don't forget, percentages times 100. Is everybody okay with that? Okay, don't use your calculator on the next one. Let's just look at the second row. For hydrogen, 1.3 grams out of 20 gives us what percentage? 1.3 divided by 20 times 100. What did it give me? Good. But the second time I had 32.5 grams out of 500. That's still 6.5, right? Last but not least, oxygen was 51.3% in both cases. If I add 42.2, 6.5, and 51.3, what's my total there? It's going to add up to what? 100. Good. So 100% of it is accounted for. You with me? Questions so far? All right. Okay. Put this. Okay, before I get into multiple I can't talk. Until I get into multiple proportions, we're going to do a little practice, okay? I want you to look at page 88. Look down at the practice problems 19 through 22. Read number 19 out loud for me, please. Okay, let's go look for number 19. Okay. Oh, my face is in the way. There we go. 19. What's my total mass? 78.0 grams total, right? What did they give me element-wise? Yeah, 12.4 grams of hydrogen. And they want to know the percent by mass of hydrogen. So look back. Which one goes on top? Which one goes on top? Look back at the equation you wrote. The mass of the element. So which of these numbers will I put? Do what? 12.4 grams of hydrogen out of, what's the total mass? 78.0 grams. I don't know what the compound is, so I'm just going to leave it grams, okay? And then we multiply that by what? 100. Calculators up. 12.4 divided by 78.0 times 100. And guys, look, we're multiplying and dividing, so we're going by 3 significant figures here. Say it one more time for me. 15.89, so I'm just going to put 0.9. 15.9, agree, disagree? Awesome. Okay. I want you to look at number 20. On page 88, number 20 says 1 gram of hydrogen reacts completely with 19 grams of fluorine. What's the percent by mass of hydrogen in the compound that is formed? Guys, they gave me a lot of information here. We want percent by mass of hydrogen, right? We want percentage of hydrogen. So how many grams of hydrogen did I have? 1 gram hydrogen. Agreed? Oh, 1.0, excuse me. So 1 gram of hydrogen over my total mass of my compound. Friends, what's the total mass of this compound? What is it? Not 19. That was how much fluorine there was. What's the total mass of the compound? Read it again. Somebody said something. 20. 19 plus 20, or plus 1, sorry, equals 20. Okay? So you guys can just divide by 20 grams. 1 divided by 20 times 100 because it's a percentage. What is my percent of hydrogen? One out of 20. What percentage is that? Are you guessing?
No.
Are you guessing?
No.
It's not 4%. 5%. Good. But look, guys, this has 2 sig figs. This has 3 when I add it together. What's less, 2 or 3? 2. So we're going to say 5.0%. 5.0. Remember, if you're multiplying and dividing, look at your numbers. Whichever one has the fewest significant figures is what we're going by. Why does this 0 count? Because there's a decimal in the number, okay? There's a decimal in the number. All right, take a minute, and I want you to work on 21 and 22, okay? If you need to, talk to the person nearest to you and work together. You're doing 21 and 22 on page 88. All right, so let's do 21. 21, what do I know? 3.5 grams of whatever X is. What else? Okay, and then it says, what's the compound? When I put it together, it's just X and Y, one of each, yes? Yes? What's your total mass here? We're going to add this up. 14 grams even, right? And remember, when you're adding and subtracting, whichever value has the fewest decimal places determines how many decimal places are in your answer. Well, here they both had a tenth, so I'm just going to write it down like this. Okay. Let's go find our percentages now. For the percentage of X, I'm going to put the mass of X over the what? The total mass. That's a 4. Okay, good. And I'm going to multiply it by 100. Okay, 3.5 divided by 14.0 equals 20 what? 25, which is okay because this number on top, the numerator, has 2 sig figs, so I'm good to answer with 2 sig figs. That should say percent X. Okay, guys, I could do a whole nother problem for Y, but guys, if it's just X and Y, what's the rest of the compound? It'd be 75, right? What's 100 minus 25? Okay. If there's only 2, or to find your last percentage, just subtract from 100. Okay, so 100 minus that 25% X is going to give me what's left over, which is Y. All right, let's go look at 22. It says 2 unknown compounds are tested. Compound 1, so I'm going to go ahead and write this down. Compound 1 has what? 15.0 grams hydrogen. And how many grams of oxygen? 120? Is that right? Okay. Compound 2 has 2 grams of hydrogen and 32 grams of oxygen. All I've done is write down what they told me in the question. We okay so far? We okay? All right. To determine if they're the same, all you got to do is figure out the percentage of that hydrogen, right? Let's figure out our percentage of hydrogen in 1. What's my total mass of my compound here? I'm going to go ahead and do this addition too because I want to get it over with. All right. Are we okay? Get your total mass. For my percent of hydrogen here, I'm going to put the mass of hydrogen, so that's 15, over the total mass, 135, and I'm going to multiply that by 100. 15, just kidding, can't read my own handwriting. 15.0 divided by 135.0 times 100. I did not click the times button. What'd you get? And I need 3 significant figures because of 15.0. 11.11, but remember, because of 15.0, that's only 3 significant figures. What am I going to write down? 11.1. Awesome. We're going to do that same thing for compound 2. I'm going to put 2 grams of hydrogen over 34 grams of compound times 100. Hit me. Did it again. Keep not hitting the times button. What's my percentage in compound 2? 5.8. Okay, but look again here. I've only got 2 sig figs and 2.0 grams. So I'm going to go with 5 point, round that bad boy up, 5.9. Is that the same percentage for each compound? No. So is it the same compound? Say it like you're mad about it. No. They are not the same compound because that ratio is not the same. Okay, if they had the same percentage, it'd be the same compound, like we saw with the sucrose a few minutes ago. Different amounts, but same percentage means it's the same. Okay, if you have any questions, go ahead and ask those now. Okay, so that's the law of definite proportions. Each compound has its own formula and own percent by mass. But there's also the law of multiple proportions, so be sure you get that one down. The law of multiple proportions. Law of multiple proportions states that when different compounds are formed by a combination of the same element, different masses of one element combine with the same mass of another in whole number ratios. And you're like, what? Just hang on and write that down, and I'll go over the examples. So we've got 2 different compounds here with hydrogen and oxygen. One is hydrogen peroxide, H2O2, and one is water. What's the difference in those? H2O2 versus water, H2O. Peroxide has the 2 oxygens in it, so that changes that ratio from 2 to 1 to 1 to 1, right? 2 to 2 is the same as 1 to 1. So, guys, can you drink hydrogen peroxide? No. That's really not smart. Please don't drink hydrogen peroxide. You can use it to, like, clean your mouth out, but spit it out. You can use it to clean out cuts, but please don't ingest it. Water, can you ingest it? Yeah. So 2 totally different compounds because that ratio is different, all right? They would have different percents by mass. So if they're going to have 2 compounds with the same elements, you see how that ratio has to change? So for nitrogen and oxygen, there are like 4 or 5 different compounds made of just nitrogen and oxygen, but they've always got a different ratio, okay? Like one is NO, nitrogen and oxygen 1-to-1 ratio. There's another one that's N2O5. That's a 2-to-5 ratio. You see the differences? Totally different compounds, totally different properties. Questions yet? Okay. Oh, I'm still writing. Just kidding. Click that. Click that. Okay, let's look at copper bonding with chlorine. In this first compound, here, what's the percentage of copper? 64.20. In the second compound, how much of the copper is there? Good. Now watch what we do. We take the mass of the copper and the mass of the chlorine, and we're going to divide them. We're going to find that mass ratio. Okay? 64 divided by 35 gives us to a 1.793 to 1 ratio. Okay? Here, if I did the same thing, my ratio is going to be different. Okay? And you always want to have it compared to 1. That's why you divide them by each other. Take 1 second. I want you to look on page 89 at figure 20. Find figure 20. Find figure 20. Compound 1 versus compound 2. See, that ratio in that compound 1 is a 2-to-1 ratio. Do you see the different bars there? 2-to-1 ratio. Compound 2, it's more like what? What's that ratio of copper to chlorine? It's more 1-to-1, okay? So that tells me that they are 2 different compounds. If the ratio varies that much, they're 2 completely different compounds. And we'll go over how you know that later on. Go ahead and flip the page to page 90. Flip the page to page 90. Look at that picture at the top, please. Compound 1 is copper 1 chloride. What color is it? Yeah, you could say yellowish, greenish, something like that. What is compound 2? It's blue. Good. Guys, different properties because they're different what? They're different compounds. Now, guys, when we talk about iron oxide, we could talk about rust. What color is rust? Reddish brown, right? Or we could talk about magnets. What color are magnets? Grayish black, right? 2 totally different types of iron oxide. Okay, so go ahead and let's work on our section check and our essential questions in the activity. And then you're going to do a quizzes that reviews all of this chapter, okay? Next class, we have our chapter 3 review. We're going to work together on some stuff, go over some more issues. And then on Friday, we're going to take a quick quiz over chapter 3. Are we all clear on what's going to happen this week? Okay, remember the section check is in the McGraw-Hill platform. So you'll go through Clever, take that 5-question quiz, upload a picture of your score, and then submit it in the activity. Any other questions? Okay.